Hi, welcome back to PA Tech Talk. Do you still use a light switch to turn on and off your lights? In this episode I thought that we should take it into the next century and add a Wi-Fi module to our STM32 microcontrollers. And I'm using a module for this and communicating using the UART and AT commands. In the coming video I will also add on the service for MQTT, where we can actually connect up to our Home Assistant or something equivalent. The module that I choose to use in this project I took from the manufacturer Quectel. And they have several modules, and if you just take a look on their page product selector for their Wi-Fi modules, there are several. And the one that I finally got stuck with was the FCM100D, and today I would choose instead the FC41D, that is a newer and more supported one. Same software, same AT commands, so you can use them transparently, either one, but in this case I will use the FC100D. To download some firmware and stuff in it, you use a tool from Quectel called QFlash, and they also provide the binary files for them. And also when you evaluate the AT commands, they have a tool called QCOM, and that enables you to send the AT commands on an easy way. To be able to easily interface this module to the STM32 Nucleo kit, I decided to go with a PCB that I custom made. And there is a free tool online called EasyEDA, which you just sign on, and there you have, in this case, the schematics. It's not a very complicated project this, but it's easier to just use an Arduino shield. So there you have the PCB or the schematics of the module, and then eventually this is the PCB. And then you migrate all these into the JLC PCB manufacturing for a very reasonable cost. And this is not a paid collaboration with JLC PCB, but I think that they are great. So I actually decided also to put some surface mounted components on the back side of the PCB, just of ease. So to start creating this project, I have decided to work with a Nucleo board, the STM32G071. And I just started a new project, and here is the cube configurator. And I have started with setting the clock to what it can perform, so that is 64 megahertz. And when I started the project, I just stopped all presets and set everything from the very beginning, and all I have done is for the serial wire debugger there. And I also have two UARTs. I have the normal UART 2, which is connected to the ST-Link for debug information. And the other UART I have, or the UART I have, is the UART 4, which are connected to the Wi-Fi module. And the first UART is just a normal UART, and it's 115 kilobit, and that is mainly for teraterm debug messages. The other one, the UART 4, is for then connecting to the module, and there I also had an interrupt connected to this one. The first UART 2 is using the polling method. And to note here also is this interrupt is not only for the UART 4, it's also for the UART 3 and LP UART 1. So several instances can actually create the same interrupt, so that we will see in the code later on. So I have generated the project, and I also have two files which I have included in the project. That is the Wi-Fi.c and the Wi-Fi.h. And if we take a look first of the Wi-Fi.h, and of course I put them in the include files in the source. So in the include files I have the Wi-Fi.h, and in the source folder I put the Wi-Fi.c. So there is where they are resided. And the Wi-Fi.h then If you don't run the STM32 microcontroller, then you need to change this include file to match the microcontroller that you are using. And you also need to set your own SSID for your Wi-Fi network, and also your password for your Wi-Fi network. And then there are some more stuff here. These we will take a look in a later stage, where we will also add a display to this project. So these are not in play right now. And here you also see the functional prototypes within the Wi-Fi.c file. And also this pass is also something that we will use in the next session. And if we take then a look in the Wi-Fi-C, where we have here, we have of course the Wi-Fi.h includes, and also the main.h. You need to have that one as well there. And there you have these some small functions that I have reset. We have init, we have connect to access point, we have IP info, and we have the pass network information. And these AT commands, that is something that you'll need to look into, the AT command set for your Wi-Fi module. They are different altogether. And the pass is something that we won't be using in this episode. And then we have also the AT command to send to the Wi-Fi module. So here we have the UART4, which I said was connected to the Wi-Fi module. And whenever I send something to the Wi-Fi module just for debugging, I also would like to have the same message sent to the debug UART, so I see what is sent to the Wi-Fi module. That is not needed. That is something that you can take away from your design, but I thought it was a nice thing to have in the development phase. And then there is also, when you send something to the Wi-Fi module, the Wi-Fi module normally respond with something, and this is a function then to wait for the needed response that you are looking for. And that is also with the timeout, so you can set that it doesn't wait forever, but if it doesn't get the needed response within a certain timeout, then you will get an error. And the wait for the response, what the response is declared here in the Wi-Fi.h. Here I have defined something VLAN connected strings, and what I then expect back from the Wi-Fi module is this string. So that is what I'm looking for. So when the Wi-Fi module says it's VLAN connected, then I know, okay, good, then I can proceed to the next stage. That is not also 100% needed. You can just have a long timeout and wait, and then hope for the best and expect that it's connected and go on. But I wanted to have some sort of a closed loop, so I know that there is something connected to it. And so it's waiting here for the string. If it's received, then it will return HAL OK. And also it will print out the expected message received in the terminal. And if it doesn't work, then it will get to this part where it's failure. It's an error handler, and then we go down to this error handler where it prints out a message on the terminal what is gone wrong actually. Great, so then we can move over to the main C file and to the top where we of course then have the Wi-Fi.h as well. And since we're using some printfs and stuff, we need to have some strings and standard ios.h included as well. Some buffers need to be declared. The UART handlers are done by the CubeMX, so they have the UART2 and the UART4. And the private functions prototypes, which are also declared for us with the CubeMX. And here are the user code begin functional, private functional prototypes declared, where I have declared my prototypes in this application here. Then we go down to the user code, and where we have then the transmit function. We have the UART init function, we have the transmit debug function, and then we go down to, so these are just declared, and when we then go down to the main file, so when we then come down here to the where user begin to, we have the UART in it, and we have the UART in it up here, where we say where we initialize the UART 4, and we actually set the buffer, and we start the interrupt handler. So whenever there is something incoming, it will trigger the interrupt. And then we have the Wi-Fi in it, and then we go down to the Wi-Fi.c, where we then send the first command to the module, create this command, and then we send it using this Wi-Fi send AT command. When we are back main C there, and then we have a small delay to actually get the Wi-Fi module to reset. Then we have the reset debug terminal, and when we then go to see what that is doing, we have that in the Wi-Fi.c file. So what it does send it not to the UART2, so that is the for resetting what is printed in the TerraTerm window. So when you have a lot of messages and you have run, then the TerraTerm window will be full of information. So that is just to clear that information, and this string then clears the information and put the cursor on the home position. Then after that we get the first Wi-Fi connection, connect to access point. So we then go to connect to access point, and then we have a command called at.qstaap info, and also it needs to then have the SSID and the Wi-Fi password, and those were that we declared in the Wi-Fi.h. So they are declared here. So when you have set these, you will have the right information sent. And after that, it's waiting for the respected response, and that is the VLAN connected string, and the VLAN connected string is this one. So we are waiting or expecting this string to be reported back from the Wi-Fi module. And then we send, if there is any problems with it, then we send that there is an error, and we print that out on the terminal as well, and then we handle the errors. But if this went well, then we go to the next step, and then we get this Wi-Fi IP info, and we then go up to the Wi-Fi.c again. So then we send the next IT command to our module, and that is the AT plus qgetIP and the station. And then we wait for that information to get back to us. And that will be printed out also on the debug terminal. So wait for the response there. And then this command passed the network, but that will be handled in the next session, and that is mainly for displaying that information on the display. That is what is done. Then it's just a loop there, so nothing else happens. But we also need to take a look into the callback function on the UART4. So here we have under user code begin for the UART receive complete callback function. And I said that we are using only callback function or the IT or interrupt function on the UART4, not on the UART2. So here is only for the UART4. So whenever this is triggered, the UART, HAL UART receive complete callback, that then you get an interrupt here when the RX is complete, and then the first thing that I do is make sure that it's UART4 that has triggered this interrupt. As I said, there could be more than one interrupt source for this interrupt vector, and if we go back here we can see here there are several that could actually trigger this interrupt. So I just make sure that it's UART4. So if it's UART 4, then we go on and looking for, so we don't overrun the buffer. And we also look for this end of conversation, that the control or backspace N. And then we zero terminate also the package, and we send that also to the UART2 debugger. So whatever we receive on the UART 4, we also print out on the debug terminal. And then we start the interrupt again. So that is the complete code. And if we then just build the program, it set 0 errors, 0 warnings. And if you then have also connected the board to your computer, we can try to download the code to your computer. Like so. And I will make some changes to the display so we can actually see the debug terminal as well. We won't be doing much of a debugging here, but so now you can see that I have a lot of information here already. So what we can do then, we can clear the screen and clear the buffer. You can do that manually each time, but you can also do it with this command that I showed. So we just run the code. Now you see everything was cleared on the terminal. And it's trying then to send a command to it, and it says OK, and it received the VLAN connected, and it says then expected message received. This is just an extra information for the debugging. It's not necessarily. But it's nice to know that there is actually a VLAN connected. And I also put a timeout on 15 seconds if there is any problems with connecting. And if the timeout will happen, then there will be another error message that it didn't complete it, and then all program stops. But since we got this VLAN connected, we get to the next. So in this stage, we actually have IP connection, and we have an IP number. So then I ask, what IP number do I have? And I get this IP back from my access point and my DHCP server. So I get all this information back, which information I have. So this is the end of this session, and the next session I will add on a display, the small OLED display, where I can then not only use this print terminal information, but also on a display, as you saw in the very beginning. And in the third one I will also add MQTT to it, so that you can send information to your Home Assist, for instance, or something else, to connect some real world lamps or temperature sensors or whatever you want. Hope you found it interesting, and if you learned something, give it a big thumbs up, and if you're not a subscriber, please consider to do so as well. And note that I'm not a C programmer, so then many of you are, and there are a lot of information that you can change in this and make it better. Please do so. The code will be uploaded to my GitHub page, and all links will be in the description below. So until I see you next time, stay safe. Bye.